We're going to talk about simplifying algebraic expressions. Yesterday I kind of introduced algebraic expressions to you where you had to simplify them using distributive property. We're going to do more of that. We're going to add to it. A couple things you need to know about algebraic expressions first though. One of them is term. The definition of term is parts of an algebraic expression separated by addition or subtraction signs. So if I wanted you to count how many terms this is, all right, you look at where the addition signs are and you count the parts in between them. So I've got 1, 2, 3, 4. So this is 4 terms. It has 4 terms. If I ever talk about the coefficient, this is what I'm talking about. It's the numerical part of a term that contains a variable. Really all that means is the number in front of a variable. So the coefficient of 3x is 3, the number, right? So that's the coefficient. I'll just write as COE. The coefficient of 3x is 3, the number part. Now if I look here, does this have a coefficient? Is 7 the coefficient? No, because does it contain a variable? No. Alright, and I'll talk about this in a second, but that's a constant. Okay, numbers without variables are constants. What about x? It has a variable, so what would the coefficient be? What's the number in front of x?
It's 0.
It's not 0, because 0 times x would be 0, so they probably wouldn't write it. What? 1. It is 1. If there's not a number in front of the variable, it's an understood 1. It's like understood I in English. You don't have to say I for someone to understand you're talking about yourself. It's the same thing here. It's an understood 1. Just because it's not there doesn't mean it's not there. Like just because you don't see it doesn't mean it's not there. Because I can times x by 1, and does it change x? No. So that's why if there's not a number, it's just 1. Just like someone did yet today on their homework, I said the answer was negative d, and someone said, well, I wrote negative 1d. Isn't that the same thing? Isn't that what I told you? Because there's not a number in front, that just means there's 1 there. Alright? Alright, write this down. Now I know I've kind of talked to you before about like terms. I've kind of introduced it. This is the definition of like terms. It's terms that contain the same variable or variables. If they have the exact same variable or variables, they're considered like terms. It's the same thing as like fractions. They have the same denominator, so we can add them or subtract them, right? Like terms that have the exact same variable, we can add or subtract the numbers in front. That's what we need to know. So here, you got 5y plus 3 plus 2y. The y, okay, is the same with the 5 and the 2. So we consider these as like terms. And to identify like terms, I usually put a symbol around them. The first symbol I always use is just an underline. And if I have more than, if I have like a different like term, then I'd underline it twice, or I'd put a box or a circle. I identify the like terms with each other. Constant, okay, I just talked about a little bit. It's a term without a variable, so 3 would be the constant. We call it the constant because the 3 is not going to change. It's not being times by anything, so it doesn't change. The 5 is being times by y, and y could change. Y could be 1, it could be 2, it could be 3, I don't know. So it's going to change eventually, right, when I find out what y is? So that's why 3 is a constant, because no matter what y is, this is still going to be 3. You're still going to add 3 to everything. Here, depending on what y is, it's going to be a different number. So that's why the numbers without variables are constants, which constants are like terms with each other. Okay? So if you had another constant in here, let's say the 5, okay, if I've circled one, I could circle the other. That would identify like terms. Sometimes I'll just underline them twice. I'll put a square. I do something around so you can see that this is like terms with this and this is like terms with that. Does that make sense? Okay. So some of your homework today is going to ask you to identify a couple different things. One, like terms, coefficients, and then constants. So what I want you to do to identify like terms is just write the expression and then underline or put a symbol around like terms. What would be like terms for this? What would I underline? 3x and 4x. Is there anything else I put a symbol around? No. If this, let's say I had like 5y right here, okay, then I would put two lines under it, so showing that 4y is a like term with 5y. But do I have that? No, so I don't put any more symbols. I just leave it as that. That's how I want you to identify like terms. That's fine with me. Okay, coefficients, here's all I want is write COE and then identify the coefficients. Someone tell me what the coefficients of this expression is. Kendall? 3, 4, 4, and 2. Good. The coefficients are the numbers in front of variables, which would be 3, it would be 4, it would be 4, it would be 2. What about constants? What would be my constant here? Do I have one? No, so it would be none. There's not a number by itself, so I don't have a constant. Underline like terms, so 6x and x, that would be like terms. Are there any other like terms? Brittany, is there any other like terms? Nope. Good. Coefficients. William, what would be the coefficients of this?
6, 2, and 1.
6. Okay, we're going to call this as -2. Okay, and not 5. 5 is a constant. Okay, it would be what? No, it wouldn't be -5 either. That's a constant. It doesn't have a variable, so it's not a coefficient. Only numbers that are times by a variable. So what would it be, Ben?
1.
It would be 1. The number in front of x, which if there's not a number in front of x, then what number is it? 1. Now my constant would be what, William?
5.
Not 5, but -5. Okay, we treat this as a negative number. Okay, so it would be -5. Easy enough, right? Any questions? Alright, write this down. Alright, when it's to simplify, what it means is just work out all possible operations. Well, the first thing I want to do when something I have like this, where it's just addition or subtraction, I want to identify my like terms, which would be 4x and 2x, right? Now, I'm going to show you what the book kind of wants you to do. You don't have to do it this way. Do it this way that we're going to do it right now, but then when your homework comes, you don't have to do it exactly this way. What they do is they want you to rewrite with the like terms side by side. So you just rewrite the expression, so everybody should write this down. They just rewrote it with the like terms side by side, which in this case was 4x and 2x. And then when you're simplifying, what that means is you're going to add like terms. If they have the same variable, then you can add them. What that means is you just add the numbers in front. So what's 4 plus 2? The variable doesn't change. I don't do anything to it. It stays the same. Is there anything I can do to the plus 6? No, so I just drop it down. There's my answer. That's all I do to simplify that. Any questions? 5n plus 2 minus n minus 6. So first thing I do is identify my like terms. The n with the n and the 2 with the -6. Now I'm not going to make you rewrite them with like terms side by side if you can just do it in your head where you add or subtract like terms. So what's 5n minus n? 4n. Because 5 minus 1 is 4. Then I do 2 minus 6. What would be 2 minus 6? -4. Have I worked everything else out? So there's my answer. Alright, before I can simplify this one, before I can add or subtract like terms, what I got to do is I've got to distribute, because I've got -3 times this. So I distribute just like we did yesterday. So I take and what I do is I make sure this is -3. Don't just write minus and then do 3 times that. use this as a negative 3. So I take negative 3 times x and negative 3 times negative 2y. So I've got 6y, and what's negative 3 times x? Negative 3x. Then I take negative 3 times negative 2y. What would be negative 3 times negative 2? Not negative 6. Positive 6. Negative 3 times negative 2 would be positive 6. So what would be negative 3 times negative 2y? Six y. The variable doesn't change. When you're adding or subtracting it, really the variable's not going to change right now. Okay, we'll work with stuff later where it will, but right now you're not going to mess with it. It's just going to stay y or it's going to stay x. All you do is multiply the numbers in front or add or subtract the numbers in front. Now, can I simplify this? Okay, so I look for like terms. I've got 6y and 6y. Brittany, what would be 6y plus 6y? 1. No. 6y plus 6y. 12y. Good. Sierra, can I do anything to minus 3x? No, so I just drop it down. There's my answer. Good. Any questions on how to do that? The problem says you have some money in a savings account. Some money. Does it tell you how much you've got?
No.
So it could be $1, it could be $25, it could be $100. Do I know? But then it says my sister has 25 more than me. So no matter how much I've got, she's got to one-up me, right? She's got 25 more. So if I've got $1, she's got how much? 26. If I've got 50, she's got. If I've got 100, she's got 125. So she's always got 25 more than me. She's kind of a jerk, okay? All right, she saved more than I do. Write an expression in simplest form, which means you work out everything you can to represent the total amount in both accounts. Well, here's what you do. You figure out how much is in your account. So how much would I say is in my account? X or Y. I like X. Yeah. Because I don't know how much, do I? So I represent using a variable. A variable is an unknown amount. How much would be in her account? Let's just say, let me put 25, which Alan's wrong, but, okay? Because this looks like if I've got 25, how much is in her account? 25. Is that what this says? It says she has 25 more than me. So she should have 50, right? Okay. So here's how I represent her account as X plus 25. Good. Because this is my account, X, and her account is my account plus 25 more. Does that make sense? So if I've got 25, she's got how much? 50. If I've got 50, she's got 75. Mine plus 25. So if I want to represent the total amount, what would I do? How do I add her account and my account? What do I do? 25 plus X, or X plus 25, and what? Is that it? Does that show me how much is in both accounts? Because that looks the same thing as her account. So would that be right? No. What would I do? Kurt?
Could it be 2x plus 25?
Okay, well, you're exactly right. It is going to be 2x plus 25. But here's what I want you to do. I want you to show her account plus my account. X plus 25 plus X. Which, if I combine like terms, Kurt, what do I get? 2x plus 25. So both of our accounts is twice of what I got plus $25. So if I have $100, she's got 125, right? Together we have 225. So that's the same thing as taking my account times 2 and adding 25. Or if I have $25, she's got 50. Well, 25 times 2 is 50. 50 plus 25 is 75. So doesn't that show both accounts? That's what you're going to have to do today, is represent both accounts plus the 25. You're going to do problems like this, so make sure you understand what you're doing. Any questions? All right, here's your homework assignment.